three streamline. So in this video, we are going to play with the triangle a little bit more, and we are going to try something different with it this time. So in the last video, we tried to divide the segment with medians, or we tried to find the midpoint for each side, and we connected those and we found centroid. In this video, I want to divide the sides in the middle, but I don't want to connect it to another vertex. Basically, I want it to be a perpendicular line for each side. So let's see how I can do that. So I have a tool here called perpendicular bisector. So if I click on this and if I click on any 2 points of the triangle, it will basically give me the perpendicular line for AC, which is also dividing AC in 2 equal parts. So I want to try it with all the 3 sides. So this is my perpendicular bisector for BC and perpendicular bisector for AB. Order actually doesn't matter here, and see what is happening. When I do this, even in this time, I get one point where all these 3 perpendicular bisectors meet. Now let's see what I can do with it. I have a circle tool here with me, and I want to keep D as a center, and I want to draw a circle with radius of DA. So basically I'm going to try to reach point A, and as you can see while I'm doing that, point B and C are also on the circumference of the circle. What does this mean? That means we have managed to find a point which is exactly at the same distance from all the 3 vertex of the triangle. This particular point in the triangle is called a circumcenter. So for acute angle triangle, this point is somewhere inside. Okay, so let's see. I'm just going to undo because I'm just getting one extra point. Let me redraw my circle. So just for the reference, I'm going to keep AD as a radius of my circle. As you can see, I can also have another radius, which I can say AB or AC. Sorry, not AB, DB or DC, apologies. And that's my circumcenter. Now let's see what happens, and this is the beauty of GeoGebra actually, that we can do this, we can have an interactive conversation here where we can change this triangle and see what happens to our circumcenter, just in case. So I'm going to try and move my point A because I want to make this triangle a right angle triangle. So I'm going to try and make it a right angle triangle. So this is my right angle triangle, and as you can see, in this case, my circumcenter lies at the hypotenuse or the longest side of my triangle, that is BC. This is also says that your center is at the BC, and it is also dividing your BC in exactly half. That means BD and DC are equal, right? Because that's BC is the diameter of your circle this time. So this is something which you can see in Euclidean geometry, that whenever you try to draw a triangle with one side of the triangle being the diameter, you will always make a right angle triangle, and as long as the third point is on the circumference of the circle, right? Now let's move on to make it an obtuse triangle and see what is happening to my circumcenter. The circumcenter is being pushed out of the triangle. So for obtuse angle triangles, the circumcenter lies outside the triangle itself. That means the point which is at equal distance from all 3 points is somewhere outside in space, not inside the triangle. So this is I'll repeat, this is a circumcenter for acute angle triangle. This is for the right angle triangle, and this is for the obtuse angle triangle. I hope you understood about circumcenter. In the next video, we will do something more fun with our triangle. And till then, happy exploring.